There is no better ape ever on this planet that can travel long distance than us in our ancestry line. This developed processes in our brains over generation of learning this. That evolutionary pressure to know how to make tools and to manufacture tools forced us to start developing a handedness. It forced us to think of using one hand to do one task and a different hand, the other hand, to do a completely different task than that hand. Passing that knowledge of apprenticeship, teaching how to make tools, put unique pressures on our ancestor line. Have ancestry at 5 or 7 million years that we also share with our closest non-extinct relatives. Say that are closest genetically related to us are a group we call chimpanzees and a group we call bonobos. Hello, and thank you for joining me. It's Brandi's World, and I'm Brandi Beckett. How do I know I'm left-handed or right-handed? I mean, yeah, you test it and then you go, oh, okay, yeah, I can write with one hand better than I can write with the other. I can throw a rock or a ball better with one hand or the other. I'm more dominant with one side than the other. That's interesting. But also, what is driving that? What is the source of that? It's not a physical thing on your body that makes you right-handed or left-handed, right? It's something within you. Like it's something that is so ingrained and innate inside of the self, inside of you, that you cannot change that. You can only discover that, right? You can look inside yourself and think about it and say, wow, I'm either right-handed or left-handed. I don't control that, but I understand that. I recognize that. I discover that I'm right-handed or left-handed. But handedness is interesting because you couldn't get it from an outside source, really, could you? Without you demonstrating your handedness or expressing your handedness, you would not be able to tell, right? Unless someone expresses their handedness to you, you have no idea what handedness they are. You just have to take their word for it, right? Handedness is innate within you, and it's interesting because it's across all humans, like all cultures. It cuts across every culture. Most humans are right-handed across the species. Now that's also interesting because we humans are the only handed primate of all the other primates on this planet, of all the other great apes, of all the other, lesser apes, and of all the monkeys and all the lemurs. All of those things are all primates, including us. We are a hominin part of the primate larger group. Our subgroup is a hominin, including the extinct humans. So all of us who are alive have ancestry at 5 or 7 million years that we also share with our closest non-extinct relatives. Brandi, who are our closest non-extinct relatives? Well, the ones still alive today that are closest genetically related to us are a group we call chimpanzees and a group we call bonobos. Now, bonobos and chimpanzees have been evolving in separate paths for 3.2 million years away from each other. So at 3.2 million years, the river in Africa, the Congo River, I believe it's the Congo River, starts to form and cut this land and divide this entire area into two. So at 3.2 million years ago, bonobos and chimpanzees were all like one group, but then this river separated these two groups of primates. So at 5 to 7 million years, around that time, our ancestry line starts to branch away from the chimpanzee bonobo line. Our ancestors were connected to, which long line connects us to them. This group had a different way of transportation than the chimpanzees and the bonobos. So our ancestry line comes from a line whose lower limbs start to get longer than the upper limbs, which created different evolutionary pressures. So while the pressures in our environment created that pressure for us to get longer legs, it has to do with us finding food, right? So at somewhere around 5 to 4 million years ago, our ancestry line, way back then, there's this group of apes, and they are starting to get their food outside of a circle. So think about this. Today, even today, all of the chimpanzees, the bonobos, the gorillas, all of these large apes, they all gather all of their resources, all of their food they need, all of the supplies they need for their nestings, for their bed, right? All of the stuff they need for group bonding. Everything in their life evolves in one big giant circle. And they can travel and they develop new circles, but everything they understand is in a giant circle in their world, right? So they know every fruit tree within like a half-mile radius of them. They know which ones are going to be ripe. They know which ones are not ripe. They know where to get their food in a circle. They know how to think through their environment in that way of gathering resources. Now, our ancestry line, they did something very interesting. They started gathering resources in a different method than a circle and knowing everything in that small circle. They started going out in straight lines and venturing outward and then coming back and finding different resources out away from their little circle of life that they were involved in their environment. This created some unique and interesting pressures. For one, you needed to conserve energy. Evolution is great with conserving energy. That's one of the main focuses of evolutionary pressures. It's to allow the evolution to happen with the least amount of energy. So conservation of energy, you find it across the animal kingdom and throughout evolution in the entire biosphere. You're going to look for signs of conservation of energy. It's everywhere. All kinds of animals are really good at conservation of energy. So as are we. We are really good at conserving energy by traveling long distances. That pressure to conserve energy and to also travel long distances to get the resources, that is one of the big pressures that shaped us to eventually become human shapes, right? There was Australopithecines before humans. So if you rewind the clock on our planet back further than 2 to 3 million years, you're not going to see any shapes of human in our biosphere, right? There's not any apes that look human-like. We haven't found them yet. They're not yet past about 3 million years. We see things that are kind of human-like. We call them Australopithecines. Examples such as Australopithecus afarensis and Australopithecus africanus. Great example of that is the tongue child, and that was discovered by Raymond Dart in 1924 and journaled in 1925. So Lucy, discovered in 1974 by Johannes, right, Donald Johannes, and that with his other students who helped him as well. So they discovered this form, which is like Lucy's something like 70% complete of mass of skeleton, missing a lot of the finger bones and stuff like that, but we find those later with other examples of her group. But Lucy is about 3.2 million years old, and these, we're not calling them human. The tongue child was not human. It was not. It was an Australopithecine, a southern ape like us, but not us, not yet. We don't start seeing human forms solid in our fossil record until solidly we can say Homo erectus. Homo erectus, no question, that is human form. If you try to describe in our skeleton everything that makes us human, you would have to include Homo erectus within that. And there's lots of other groups of human, but we first start seeing examples of Homo erectus about 1.9 million years ago. So around 2 million years ago, we start to see human things, is my point. Beyond 3 million years, we're not seeing human things. That's being conservative. We see Australopithecines, human-like things, but also not really human-like. There's lots of characteristics of us physically that they don't really have. So we start to see these Australopithecines and then later humans, but we also see a trend in a lot of the features of these ancestors of ours, these creatures. I'm not saying that Afarensis and Africanus are direct ancestors of us, because they're probably not. Our direct ancestors, we probably have not dug up and have examples of it. It's kind of like trying to say, I am going to find my great-great-grandfather at a cemetery in another country and exactly get that person, right? So if you travel to another country to find the cemetery of your great-great-grandfather and all of the names are erased off of the headstones, you may or may not dig up that exact body, but if it was the same village with the same people, the same group, sharing the same environment for centuries or whatnot, you're going to get a good idea physically of what your grandpa was like by getting an example just like him in the same similar regions, living at the same time with the same environmental pressures. So, other Australopithecines are part of our story, if not directly our ancestor line. Our story would be similar to theirs and those timelines. Our longer lower limbs than upper limbs, that was an interesting transition and it didn't regress. Once we start to see that, we start to see a lot of these hominins with these longer legs. And what does that tell us? And why are you so fixated on long legs, Brandi? Well, one, I have awesome long legs, but other than that, they're an interesting part of our story. Why? Conservation of energy. Our longer legs allow us to stride further in distance with less energy exerted. So, like a chimpanzee and a bonobo, they are knuckle walkers. Our ancestors never walked on knuckles. Our ancestry line was never knuckle walkers. That is just not good science when we assume that, right? We assume since gorillas are knuckle walkers and chimpanzees and bonobos are knuckle walkers, obviously we must be knuckle walkers, our ancestors must have came from. But that's not telling the whole story. Gorillas became knuckle walkers after they branched off from our group of shared ancestry line. Gorillas developed a way of knuckle walking that is different than the way chimpanzees and bonobos knuckle walk. And I'm going to get it mixed up. One of them do it like this and one does it like this. But they are convergent evolution. A good example of convergent evolution in a pressure of an environment that needed knuckle walking to conserve energy. If you're scrounging around the ground and up trees and back down onto the ground and you're only going in circles and you're not having to travel long distances, energy conservation is much better on all fours. So if you have longer, upper, stronger arms that get you around and you develop a system of knuckle walking, oh my goodness, you're going to get around really nice with these big, heavy ape bodies. And that's what the gorilla line did. They developed knuckle walking. Before them, Another group breaks off. I mean, there's been lots and lots of groups, but a group that still exists broke off. That was the orangutans. And orangutans travel differently than gorillas travel, who travel differently than chimpanzees and bonobos travel. So we know that chimpanzees and bonobos both had the same style of knuckle walking. They share the ancestry that developed that. And that was somewhere at 5 to 7 million years. Their ancestry starts to develop a type of more locomotion that would get them around and get the resources they need to procure. And it worked very well for them, and it's still working very well for them. So knuckle walking was developed a few times in our greater ape family of primates, right? When the apes started, ancestry got big enough where trees all the time was not really good for them. They needed to explore on the ground with those big massive bodies they were developing. There was many systems of locomotion that took hold. Different styles of knuckle walking, and our ancestry line and a few others started developing bipedalism. And that bipedal method, it worked greatly when we're able to travel long distances. For short distance, bipedalism is not a good way to conserve energy. You're exerting a lot of energy to get a short around area. But if you have to travel long distances, there is no better ape ever on this planet that can travel long distance than us and our ancestry line, going all the way back at least a few million years. We had the ability to travel long distances, and that put other pressures. That became our environment. Traveling long distances became a method of gathering resources that later turned into a method of hunting. That was amazing as well. And this long distance travel, it put other interesting pressures on us to become us, right? Us humans. What else is vastly different about us than our other non-extinct cousins, the apes, the other great apes? They are very furry. We are not. That's interesting, right? We are not, but at some point our ancestry line must have been, because we have all of the follicles. You have just as many hair follicles, little sprouts where you could grow hair and where many times fine little hairs grow, as all of the other apes. Our ancestry line was furry. Now, there's also an interesting thing about not having fur versus having fur. Furry things also are mammals. We know this. Part of being mammal is the hair, right? It's right that we learned that in 7th grade biology. You have a system to cool yourself off, and this is very important. So in warm climates, think about furry things, how they cool off. They pant, right? Your dog sweat through the things that aren't fur, the palms, the mouth, a few other areas your dog can sweat because it's covered in fur. But also chimpanzees, they're going to not be able to sweat like we do, is my point. They have to cool themselves off while carrying around fur. So they're air cooled, and we are water cooled because we sweat like no other ape ever has. We have exploited this system of sweat glands, which reduced our hair follicles' girth and amount to lower that down, have little tiny hairs going out of follicles, and develop these sweat glands all over our body. Now that we have long legs and sweat glands, guess what? We're efficient, traveling mammalian machines who now are set to take over the world in just a few million years. Also, when we got these long legs and these sweat glands, and we started to become not only gatherers and scavengers, we developed a way of hunting. Our ancestry line millions of years ago figured out that with bodies that could sweat, we can run all of the furry mammals. Well, what does that mean, Brandi? We're slow. How are you going to outrun them? Not in speed, but in time. We are lousy at running fast. We get outrun by all other mammals, basically. Think about all of the mammals in a race. You're going to lose to a horse. You're going to probably lose to a goat and outrun you. You're probably going to lose to a dog. You're going to lose to a cat. You're going to lose to elephants. You're going to lose to, think of a mammal that runs. You are probably not faster than it. We are slow in running. And our defenses are miserable because look at our claws. We developed pressures that did not emphasize and glamorize claw work in speedy actions. We would not have survived if that was the path we were on. We were on an evolutionary pressure that developed long legs and sweat glands. And now we can outrun all of those faster animals with those bigger, sharper claws in time and space. Not necessarily how fast we go, but we can keep going much, much longer than they can. Our water-cooled systems allows it. Our energy-efficient momentum on our bipedal long legs allows us to be energy efficient, and we can use less calories than them, and they're going to overheat, and it's going to cause pressures on the heart, lungs, and kidneys in these furry mammals, and they're going to drop dead. That is called persistent hunting, and we developed that millions of years ago. Our ancestors next of kin or close to kin developed this stuff, and our ancestors developed it as well, because we have these long legs, we have these sweat glands. We can literally do that today, and we can do that better than any other mammal. We are great at long distance travel. We can keep going and going and going. We're out in an environment where we don't have good defensive weapons. Our teeth are getting smaller and smaller. Our sharp teeth, they're not very sharp. We need tools. This is when handedness comes in. All apes use tools. In fact, many mammals and many other species who are not even mammals use tools. But there's a difference in our group. Our ancestor group started a trend of not only using tools, but manufacturing and teaching generations beyond them the process of manufacturing tools. That is the difference. But manufacturing tools and passing that knowledge of apprenticeship, teaching how to make tools, put unique pressures on our ancestor line. And one of those was, how do you make sharp tools with stone? Stone tools that we find at 3 million years ago, you need to process it in your brain to think out which parts of the rock you pick up, the stone you pick up, that need to be carved away to make the tool you're desired getting, whether it's a scraper, cutter, or whatever type of tool you're using. You need to figure it out. And the first kind of tools they used were kind of simple. They're big cores, and they chipped away. Sometimes you find a rock that's already kind of rigid and ragged, and they would learn to chip away parts that weren't good, so you can get a good handle on it, and you can use it in different ways to cut up a carcass you find, or to help break up some of the soil to get to the root you need to get to. So this became a pressure to use tools of stone, tools of hard objects, antlers, bones, wood, bamboo, whatever hard source you could get. If you can develop a way to make tools and show others how to make tools, it develops a pressure to make a better tool for a better use. And this process of making these tools, it forced us to think of using one hand to do one task and a different hand, the other hand, to do a completely different task than that hand. One hand to hold the object, the other hand to shape the object. So this developed processes in our brains over generation of learning this. That evolutionary pressure to know how to make tools and to manufacture tools forced us to start developing a handedness. So it appears that handedness goes back in our ancestry line at least 3 million years. Interesting, right? So it is innate in us. It's across all humans. All humans come from lines of handedness people, handedness apes, handed ancestry. We all come from an ancestry of handedness. We have that. It's part of us. We just discover it. It's just, you don't have to develop it, you discover it. Handedness is innate in us, and it comes from a source of we don't know where to pinpoint. But we know it's a real within us. And we also know that handedness can only be discovered from inside, and it can only be expressed from inside to outside. All right. Well, I'm going to wrap it up for today. We did a little rabbit hole with Brandi Beckett on hominid evolution. So, until next time, love yourself, but more importantly, like yourself, and treat people the way they want to be treated. Bye-bye for now.